Welcome back, Focus Learners, to today's Explainer. Today, we're tackling something huge. It's a topic that honestly trips up so many fresh structural engineers entering the field, often leading to actual late-night panics. We're going to completely demystify the complex American building code ecosystem for you. By the end of this session, you won't just be rattling off a bunch of random acronyms. You'll know exactly how they all fit together to ensure our buildings stand tall and safe.
Okay, let's dive into this outline and see how we'll get from the basics to mastering engineering judgment. First up, the software trap. Second, the code ecosystem. Third, core codes explained. Fourth, a real-world engineering workflow. And finally, mastering engineering judgment.
Let's hit Section 1, the software trap. Are you an engineer or an operator?
So this addresses one of the absolute biggest mistakes young engineers make. Imagine you receive a brand new steel building project tomorrow morning. What do you check first? Do you immediately fire up STAAD.Pro or ETABS? Do you start picking out steel sections? Well, if your answer involves booting up a computer program just to click around, you've kind of fallen right into the trap. You haven't stopped to ask the single most fundamental question: what actually governs my design?
See, there's a critical difference between operating software and practicing engineering. Operating software, that's just clicking buttons, blindly assuming the latest code edition automatically applies, and treating whatever the computer spits out as pure gospel. It's the classic garbage in, garbage out scenario. Practicing true engineering, though, means establishing your exact jurisdiction, deeply understanding load paths, and knowing exactly which specific codes connect to each other. Knowing acronyms like IBC or ASCE 7 is cool for a trivia night for sure, but it's just not enough to keep a building standing.
Moving to Section 2, the code ecosystem. Connecting the frameworks.
We absolutely need to stop looking at design codes as these solitary rulebooks. Because here's a massive misconception we've got to break right now. There is no single American structural code. Literally, if you stacked all the relevant documents on top of each other, they'd probably reach your knees. American structural design relies on a highly interconnected ecosystem of codes, standards, and local requirements. You can't just memorize one thick book. You must understand how they all talk to each other.
Let's move to and see how this builds in reality. It's basically a top-down waterfall. Step 1 starts at the very top, the authority having jurisdiction, or AHJ. They set the legal rules of the land. Step 2 is the building code they choose to adopt, which is typically the IBC. Step 3 flows down into design loads, where we dictate the specific forces using ASCE 7. And finally, Step 4 brings us to the actual material, using ACI for concrete or AISC for steel. If you miss Step 1, all the rest of your math is legally useless.
All right, Section 3, core codes explained. Decoding IBC, ASCE 7, ACI, and AISC.
Now, what's really interesting about this is how these four essential standards don't compete with each other at all. They collaborate. It's almost like a recipe. The IBC acts as your overarching cookbook, right? It's the framework. ASCE 7 handles your design loads and hazards, so the environment you're cooking in. Then ACI 318 dictates your concrete material design, while AISC 360 covers steel. Those are your actual ingredients. They feed directly into one another to form a complete, safe structure.
Let's take a closer look at the IBC. It's absolutely critical to realize that the IBC is merely a model code developed by the ICC. It is not automatically the law everywhere. It only becomes legally enforceable when an exact city or county adopts it, and honestly, they almost always add local amendments. Because of this, the very first question out of a professional engineer's mouth should always be, which adopted code and amendments govern this specific project? Once your framework is established, you have to ask, what forces is the universe going to throw at this structure? That is ASCE 7. Wind, earthquakes, snow, rain, dead and live loads, flood, fire, and the complex load combinations that tie them all together. ASCE 7 is essentially the ultimate playbook for determining every single ounce of stress your building is going to face.
Section 4, Real-World Engineering Workflow, Putting the Ecosystem to Work.
Okay, we've covered the theory. Now let's see how a pro actually puts this to work. Picture this. You're working on a 5-story steel office building. Your senior engineer walks up and asks, "What code bases are you using?" If you just blurt out ASC 360, you are missing the big picture. You have to trace it chronologically. You start by determining the jurisdiction. Next, check occupancy and risk categories. Then, figure out the specific wind and seismic loads. Only at the very end do you apply material standards like ASC 360.
Let's apply this to a simple steel warehouse. First, identify the building and code basis. Second, determine your dead, live, wind, and seismic loads. Third, establish your actual structural system. Where are the rafters, the columns, the bracing? Notice something here? It is only at step 4 that you are finally allowed to open your software to analyze the model. Then you design members, and finally, check constructability. The software model is totally useless until steps 1 through 3 are completely locked in.
And this ecosystem absolutely does not stop at design calculations. A successful structure has to be safe, buildable, inspectable, durable, and economical. Getting a perfectly green stress check in your software doesn't automatically equal a successful building. If the fabricator can't make it, the contractor can't erect it, or the inspector can't verify it, well, your design is just an incredibly expensive piece of modern art.
Section 5. Mastering Engineering Judgment, the Global Engineer's Mindset.
This right here is where you transition from a graduate into a true international structural engineer. To master this judgment, you've got to avoid the classic fresher pitfalls. Do not start with software first. Never ignore jurisdictional amendments. Don't lazily copy-paste wind or seismic values from an old project. Stop treating codes as disconnected books. And most importantly, never assume that just because the software output looks pretty, the design is automatically safe in the real world.
Grasping this interconnected ecosystem is basically your superpower. Learning to understand a new code system quickly is a huge global engineering skill. Whether you land a project in the USA, India, the Middle East, or Europe, your real advantage isn't memorizing one specific country's code. It's having the mental framework to decipher any structural code system anywhere on the planet.
So, the crucial point is this. It all boils down to an industry mantra you should never ever forget. Engineering first, software second, judgment always. Software is just a highly advanced calculator. Your true value as a structural engineer lies entirely in the critical thinking you do before you ever touch a keyboard and the sharp judgment you apply to the results.
I want to leave you with this final thought. When you open a design standard on your very next project, will you just act like an operator and ask, what does the code say? Or will you step up and ask, why does it say this? What problem is this preventing? What hidden assumption is behind this equation? Asking why is the true mark of a master structural engineer. Thanks for joining me for this explainer, and keep pushing your understanding to the next level.